Lesson: Bias Detection and Fairness in AI Models. Bias detection and fairness in AI models are pivotal for ensuring that AI systems operate equitably and justly across diverse populations. This lesson will explore actionable insights into identifying and mitigating biases in AI models, employing practical tools, frameworks, and step-by-step applications. Understanding and addressing bias in AI is not only a technical necessity, but also an ethical imperative, as AI systems increasingly influence decision-making in areas like healthcare, criminal justice, and employment. AI models are susceptible to bias primarily because they learn from data that may reflect historical or societal biases. These biases can manifest in various forms, including but not limited to gender, race, socioeconomic status, and more. For instance, a famous case involved a recruiting tool developed by Amazon, which favored male candidates over female candidates because it was trained on resumes submitted over a 10-year period, most of which came from men. This example illustrates how biased training data can lead to biased outcomes, underscoring the importance of scrutinizing the datasets used to train AI models. One effective step in bias detection is the use of fairness metrics. Fairness metrics are mathematical formulations that aim to quantify bias in AI models. Commonly used metrics include demographic parity, equalized odds, and disparate impact. Demographic parity requires that the decision rates be equal across groups, while equalized odds demand equal false positive and false negative rates across groups. Disparate impact assesses whether an AI model disproportionately affects one group over another, typically measured by the 80% rule from employment law, which states that the selection rate for any group should be at least 80% of the selection rate for the most selected group. Practical tools such as IBM's AI Fairness 360 and Google's What If tool provide robust platforms for evaluating and mitigating bias in AI models. AI Fairness 360 is an open-source toolkit that includes a library of metrics for datasets and machine learning models to test for biases, as well as algorithms to mitigate bias. For instance, it offers pre-processing techniques like reweighting and resampling to adjust the training data, in-processing techniques such as adversarial debiasing, and post-processing techniques like equalized odds post-processing. On the other hand, Google's What If tool allows users to visually inspect AI model performance across different groups, facilitating a better understanding of model behavior and potential biases. These tools are invaluable for practitioners aiming to ensure fairness in AI systems. Beyond measurement and toolkits, frameworks such as the fairness, accountability, and transparency in machine learning principles provide a comprehensive approach to bias mitigation. These principles advocate for transparency in AI processes, accountability for AI-driven decisions, and fairness in outcomes. Implementing these principles involves a holistic approach that combines technical, ethical, and legal perspectives. For example, transparency can be enhanced by documenting the data collection and model training processes, while accountability can be ensured through regular audits and impact assessments. A practical step-by-step approach to addressing bias in AI models begins with problem definition and understanding the context in which the AI system operates. This involves identifying the stakeholders affected by the AI system and their specific needs and concerns. The next step involves data collection and preparation, ensuring that the data used is representative and free of historical biases as much as possible. This might involve augmenting the dataset with additional data or employing techniques like data reweighting to balance the representation of different groups. Once the data is prepared, the next step is model training and evaluation, where fairness metrics are used to assess the model's performance across different groups. If biases are detected, bias mitigation techniques can be applied. Pre-processing techniques modify the training data to reduce bias before model training. In-processing techniques modify the learning algorithm itself to make it less sensitive to biased data. And post-processing techniques adjust the model's predictions to ensure fair outcomes. An illustrative case study involves the use of AI in predicting criminal recidivism, where models were found to be biased against African American individuals. In response, Researchers employed fairness constraints in the model training process to ensure that the false positive rates were equalized across racial groups. This intervention significantly improved the model's fairness without substantially sacrificing accuracy, but demonstrating the feasibility and effectiveness of fairness interventions in real-world scenarios. The final step in the bias detection and fairness process is monitoring and continuous evaluation. AI systems should be regularly tested and monitored to ensure they remain fair over time, especially as new data becomes available. This involves setting up feedback loops where the outcomes of the AI system are continuously assessed and adjustments are made as necessary. Establishing a culture of continuous learning and improvement is crucial for maintaining fairness in AI models over their life cycle. In conclusion, bias detection and fairness in AI models are critical components of building ethical and trustworthy AI systems. By employing fairness metrics, utilizing practical tools like AI Fairness 360 and What If tool, adhering to frameworks like FAT-ML principles, and following a structured approach to bias mitigation, AI professionals can effectively address biases in AI systems. These efforts not only improve the equity and justice of AI outcomes, but also enhance the credibility and acceptance of AI technologies in society. As AI continues to permeate various aspects of human life, ensuring fairness and reducing bias in AI models will remain a paramount concern for AI practitioners and policymakers alike.